students, I'm happy we are back together again. Thank you for your patience. Welcome to your basic science class. It's your dear Mr. Samrat Adewale. Today, we'll be talking about friction and gravitational force. So, at the end of this video, you should be able to know the meaning of friction, its advantages and disadvantages, as well as how to reduce friction. You will also be able to know more about gravitational force and how to perform simple calculations on gravitational force. Okay, without wasting words, under friction, you will learn its meaning. You also learn its advantages. Then we'll now move on to disadvantages of friction before we talk about means of reducing friction. Okay, let me introduce you by taking you to the past. Please check this picture. This man you are looking at in the picture, his name was Leonardo da Vinci. Leonardo da Vinci was an Italian scientist, a genius. In 1493, this man actually worked on friction, the first scientist to discover friction. He did so many research work. He did not publish his works. So bad. He died without most of his work known to anyone. Many years afterward, a French scientist rediscovered friction. And this man, whose name was Guillaume Hamilton, in 1600, postulated 4 different laws of friction. He really worked extensively on friction. So these 2 great men were actually credited for discovering friction. Now, enough of the history. Let's now go on and see what friction is to you in your everyday life. Rubbing your pens together, you are actually displaying friction, because in between the 2 surfaces of your pens, there is a force that is trying to stop the movement of the pens over each other. That particular force is called friction. While you rub them together slowly, you can tell that something is trying to stop your ends from rubbing against each other. If you keep rubbing over each other, you will discover that you start feeling some kind of warmth. That is frictional force, giving you that warmth there. Not only that, do you know that by striking 2 stones together, you can actually make fire? Yes, it is real. Our forefathers used this crude technology without knowing that they were actually making use of frictional force. They were able to produce fire for so many years by merely making use of stones. You can imagine. Today, we have a better way of doing things, but friction is still important to us. Okay, no. Not only that, do you also know that friction actually helps us to walk without slipping? It helps us to walk without falling. Okay, by merely applying small amount of force, we can actually stop. That is so great. The friction between our legs and the ground. Do you know that a matches box, by pulling out the matches stick, you can actually make fire, but not by striking it on the matches box. Yes, you bring out the matches stick and strike it against the glass. Oh, you saw that. Fire will surely come out. So that is to tell you friction is at work there, between the head of the matchstick and the surface in which it is in contact with. Beautiful. Okay, my dear students, it's important for us to also know the meaning of friction. So let's go on and see what friction really is. So friction can be defined as the force that opposes the motion between 2 surfaces in contact. So this force is always between 2 surfaces. Anytime they are trying to move over each other, it tries to prevent them from doing so. That is called friction, or simply frictional force. Okay, now please look at this man trying to pull this box. You can tell that this man is really exerting a lot of force. But with this shear reaction force, there is another force trying to move in its opposite direction, trying to stop the movement of that box. That is friction. It slows things down. And it acts in a way that it is in the opposite direction to the force that is actually pulling that particular object. Frictional force. Okay, do you also know this fact that friction is greater when the surfaces of the body in contact are rough? That is true. If the surfaces of the body in contact are smooth, friction will be really, really low. That means large surface equals large friction. Very good. Note that. And also smooth surface equals small friction. Now, with that at the back of your mind, let us now go on and see advantages of friction to us. You can imagine so many things we do today without us knowing that without friction, it will not be possible. Take, for instance, the way we walk and the way we stand. If there is no friction between the bottom of our legs, that is the sole of our shoes, and the ground, we will not be able to walk. We will slip off. Yes. You also know that frictions allows a vehicle to stop. By mere applying brake, friction does the rest of the job. You can often see the so-called screeching of the tires on the road every time, or around you once in a while. So that is to tell you a kind of force has just generated this. Okay. Let's look at the other one. Friction actually allows sharpening of tools. No friction, this will not be possible. Okay. What about the way we write? You do this. In fact, you are doing it right now. Do you know that if there is no friction between the pen and the book, nothing will happen? That is interesting. So it allows us to write. Friction also is the reason why parachutes can work. And naval officers, those armed forces that work on air, they are called air forces. These people, they can jump no matter the altitude. With their parachute, they feel safe. The friction between the air particles rushing against the balloon of that parachute actually stabilizes their fall in the air. Okay, do you also know that friction is actually the reason why airplanes can land safely? If there was no friction between the plane body as well as the air particles, take it or leave it, the plane will keep flying, and for it to stop, it will have to collide against a very heavy object, which will actually cause plane crash. This is very, very important. Do you also know that friction actually is the reason why belts can stay put on pulleys? They are fixed in the right position if friction actually exists. But if there is no friction, this will not happen. In fact, the belt will actually slip off. You must have seen this oftentimes when you're grinding pepper, or they sent you to grind pepper, and then you just see the belt or the grinding machine slip off. That is to tell you that the friction between the belt and the pulley has reduced greatly. Okay, what about ladder? There is friction between the foot of the ladder and the wall. So the friction is also the reason why some rocks in the outer space, before they enter into our planet Earth, they actually get burnt. That is very interesting. As you can see from this picture, had it been these rocks were able to get into our atmosphere and get to the Earth, they will have caused disasters. But they get burnt in the outer space there before they enter into the Earth, because there is friction between the air particles and the body of these rocks, causing great amount of heat, which leads to them getting burnt, and they diffuse off, okay, without us knowing. Okay, now let's now go on and see if there was no friction, what do you think would have happened? For just 5 minutes, 10 minutes, what if there was no friction? Now, watch this video.
Friction. Yeah, celebrate friction and be grateful it exists, because you don't know what you've got until it's gone for 1 minute. cut the fireworks, matches don't work anymore, and you can't use lighters. In fact, you can't pick anything up because your ability to grip and pick things up is due to friction. Anything you were holding on to, the moment friction ceased to exist, would instantly fall to the ground or fly out of your hand. If you were walking when friction disappeared, your legs would still work, but you wouldn't go anywhere. But if you were in a moving vehicle, you'd keep going and going and going and going until you crashed into something. Your brakes are friction. In fact, for that one seemingly endless minute of chaos and destruction, terminal velocity would cease to exist, meaning that anything in motion would be a deadly projectile. At least you wouldn't get rope burn. But that tree, that penny, that runaway train is actually the least of your worries because within just 1 minute of losing friction, actually within an instant of losing friction, the whole world would just become one big, formless, featureless blob. Considering that everything on Earth is composed of atoms and particles, and that all atoms and particles are held together by friction, well, what do you think you get when you take away friction? Nothing. You lose everything, instantly. So, if you've ever wondered why skidding cars and baseball slides look so cool, well, just be grateful for friction. Yeah, it can make life hard sometimes, but it beats losing literally everything on this planet. So go on, try it for yourself. Take a walk and feel the friction between your feet and the ground. But, you know, there's good friction and then there's awkward friction, like at the workplace.
Oh, that is true. There is good friction and then there is awkward friction. Well, let's now look at disadvantages of friction. Please follow me and see number one. Thought number one is interesting. It's the one that generates it. You know, we started this video by asking you to rub your hands, the palms of your hands, against each other, that you will feel warmth. Of course, you can imagine two gears moving against each other. A lot of heat that will be generated. That is the disadvantage of heat there for you. Of friction there for you. Also, friction produces wear and tear because the parts of machines are often in constant touch with each other. So they are in contact with each other every time. So because of friction in between the two parts, there is a kind of gradual breakdown in the parts of these machines. Not only that, do you know that friction also reduces efficiencies? So it doesn't make machines, devices, to work optimally at 100% the way they were designed to work. Because as any parts of these machines or devices are in contact, in as much they are in contact with each other, friction will try to reduce their movement and that will affect their functions. Okay, so do you also know that friction causes noise? Yeah, it produces a lot of noise as those parts of machines are rubbing against each other, but friction is trying to stop them, and then the next thing you start hearing, oh, that kind of noise can be sometimes irritating. Yes, and eventually it leads to breakdown of the machine with time. Okay, friction actually causes forest fires. If you don't know that, now you know. No, you've heard of Amazon fire before. Think about it. That the leaves are brushing against each other. Remember that friction is actually a force between two surfaces. So as the leaf brush against each other, you can imagine that a kind of force the kind of heat that will be generated. That is interesting. Now, this heat generated is the one that leads to fire. And before you know it, the whole forest is on fire. The whole forest is on fire. Interesting. Okay, because of the need to reduce friction, so we have to engage in certain techniques, invest in different methods of reducing heat, and that will automatically increase the cost of production, which will make the price of goods to rise. Friction has its advantage. In fact, its advantages and also its disadvantages. Okay, Now, let's look at how we can reduce friction. Since we know that friction is very good, in fact, is a necessary evil. So many things we can do just because of friction. Yet, we still need it sometimes to to even go away, if possible, when we don't need it. Okay, so let's look at ways of reducing friction. One, you can reduce friction by making use of lubricants. Those lubricants are always in form of oil and grease. By applying the lubricants, we'll be reducing friction. Okay, not only that, we can as well reduce friction by smoothing. Okay, or simply by polishing the surfaces that are in contact. Remember that smooth surfaces actually will lead to small friction. Lastly, we can also reduce friction by making use of ball bearings. You can see that ball bearings over there, like a ball. Yes. So they are, or you can call them rollers. So they actually are found in parts of vehicles and your normal Okada or Marwa. Okay. So now, having known all this, that is that about friction, it's time for us now to look at what gravitational force is all about. Okay, then we can now summarize what we have learned so far on friction, then combine with that of gravitational force. Okay, so under gravitational force, what are we going to be learning? So here we'll be learning about the meaning of gravitational force. We'll also be learning about value of gravitational force, and lastly we will learn how to calculate, how to solve problems involving gravitational force. Okay, so let's start with what gravitational really is. Think about this. This ball falling from down the stairs. Oh, if there was no gravitational force, this cannot happen. Think about this. You jumping up and down is because of gravitational force. Whether you do frog jump or you do skater's drill, it is all because of gravitational force. That is interesting. Now let's now go on and see the meaning of gravitational force. Simply put, gravitational force is actually that particular force that pulls all objects down to the earth. You cannot imagine if things were meant to be floating. They will keep, in fact, there will be a time when everything we will just escape into the space. But thank God for this force that pulled everything down. They keep everything down on earth. And that is the reason why you are able to sit down right now. You are still able to hold your phone. You are able to pour water, and the water will fall on the ground. Oh my God. Gravitational force. Very, very important. Okay, so what do you think will happen to us if there was no gravitational force for just 5 seconds? Just as we have seen what will have happened to us if there was no friction for just 1 second. Let's see what would have happened to us if there was no gravitational force for just 5 seconds. Please watch this video.
The sky is falling! The sky is falling!
Get a grip. The sky isn't falling. It's getting sucked into outer space. And so are all the oceans, and the trees, and cars, and roads, and bridges, and the Earth's core, and you. So get a grip, and hold on tight.
Hang on, kid!
You're in for a wild ride. This is What If. And here's what would happen if we lost gravity
For 5 seconds. That is what will happen. For just 5 seconds. Everything on earth will be disastrous. Vehicles will not be able to move on the road because what keeps them on that road is not only friction but gravitational force. And you see that? You yourself will not be able to walk. You'll be flying up to the point that you will escape out of the planet, and when you get to the space you keep moving and moving and moving, and that is it. If there was no gravity at all, do you know there won't be night and day? That is interesting. Please, enough of that. Let us now look at more about gravity. Do you know that any object which is allowed to fall freely will be pulled to the earth by gravitational force? What we are trying to say here is that if you allow an object to fall without disturbing that object, or without any external force disturbing the object, that object will fall down to the earth, will be pulled down by gravitational force. Exactly. But is that what happens? No, every time. Not every time. Balloons and feathers, when you leave them, you allow them to fall freely, they don't fall down on time. They don't hit the ground on time. Why? Because they are still being supported by air. Air carry them. So the air, as the air carries this object, you feel, oh, they don't have enough gravitational force acting on them. But wait a minute. I have a question for you. Hammer and feathers, if dropped, which of them will hit the ground first? Think for just 2 seconds. Anna, I know you would have gone for that. Okay, so, but the right answer is actually both of them. Yes, when both of them are dropped at the same time, they will hit the ground at the same time. If you don't believe this, please let me prove it to you. How will I prove it to you? Please look at this man. Have you seen him before? Yeah, in your textbooks, of course. Let me give you a short biography of this guy. This guy was actually born in 1930 and he died in 2012. Somewhere in United States of America, a place called Ohio. This man was an educator and a military pilot. Do you know he was a NASA astronaut? Judging from the way he's dressed here, of course. This man was famous for being the first man to land and walk on the moon. Bam! Wait, you have gotten his name. What do you think? What do you think is the name of this man? Okay, being an astronaut and famous for being the first man to land and walk on the moon. Yes, you got it right. His name, full name, was Neil Alden Armstrong. Neil Alden Armstrong. Do you know he did not only walk on the moon, he also proved a scientific law on the moon. In fact, the question I asked you before about hammer and feather, you had to go to the moon to actually prove it. Do you know what we should do now? Maybe we should also go to the moon to see whether it was true or not, to prove that hammer and feather can fall down at the same time. This is Alden Neil Armstrong with hammer and feather. Watch.
Well, in my left hand, I have a feather, and in my right hand, a hammer. And well, I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects and gravity fields. And we thought where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon, and I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? And that proves that Mr. Galileo was correct in his findings.
Superb, Dave.
Well, I always say there's nothing like a little science on the moon.
That is true. Nothing like a little science on the moon. It proved it right. You saw that hammer and feather, they dropped at the same time. Why? Because over there is gravitational force, but no hair. Can you see that now? But because we have hair here, hammer dropped down first before feather. Hair interfere by blowing feather around, and so it doesn't hit the ground on time. But you just saw that now in this video, that they can hit the ground on time. Now, thank you for that. Value of gravitational force. Let us see what is the value of gravitational force. Now, please, I want you to know this, that gravitational force is actually the product of mass and acceleration due to gravity. So mg, m there stands for mass of the body, while the g stands for acceleration due to gravity. So that is the formula for gravitational force. But here's the thing. Do you know that gravitational force is conservative? What does that mean? It simply means that it is conventional and not changing. It doesn't change. So we have agreed on a particular value. This is interesting. And you want to know what that value is. The number is simply 9.8 Newton. So 9.8 Newton is actually a constant. So anytime you are being asked, what is the value of gravitational force? Simply say 9.8 Newton. Okay, now that you have known this, now we can go on and use this value to make some simple calculations. So, please pay attention. I hope you have your biro with you if you don't have it before. Okay, let's start with this question. An apple falls from a tree to the ground. If the height of the tree is 3.2 meters, what work has been done by gravity in moving the object? 2. Calculate the gravitational force on the object. Okay, now you know the question. Let's go on now and solve this problem. Remember, we have two things to solve. An object falls from A to B, that is from the tree to the ground, through a height of 3.2 meters. So we are looking for work done, and we're also looking for gravitational force. So our parameter says that we should find work done, and we should also find gravitational force. Let's start with work done. Work done is given as mgh. Please write that particular formula. Work done is mass times acceleration due to gravity times height. Okay, now let's look at what we are given in the question. We are given mg. You don't know? Yes. If you don't know before, do you know that 9.8 Newton that we just discovered before is also mg? Yes. We said gravitational force is the product of mass and gravitational and acceleration due to gravity, which is 9.8 Newton. We also have it that the height is 3.2 meters. So, since the work done is mass times acceleration due to gravity times height, that is mgh, then let's make use of what we have. Mg is 9.8 times our height, which is 3.2. What will this give us? 31.36 joules. That is the answer. As simple as that. You can go over it once again. Now, what about gravitational force? Since gravitational force is a conservative field, that means that it doesn't change. Therefore, we can say gravitational force is mg. And what is our mg? Mg is 9.8 Newton. Bam! That solves the problem. As simple as that. Please, study this over and over again, and you see that it is not hard to actually perform. So, now, let us now go on and see what we have learned so far. So far, we learned about friction. That friction opposes the motion between two surfaces in contact. And friction helps in walking, standing, stopping, a vehicle, sharpening of tools, and so on and so forth. Friction causes generation of heat. It causes wear and tear of machines. Efficiency is reduced in machine as well. We also learned that friction can be reduced by using lubricants, ball bearings, and then smoothing surfaces in contact. We learned about gravitational force today. We learned that the force is the one that pulls all objects down to the earth. Gravitational force is allowed if any object is actually allowed to fall freely on their own. They will hit the ground at the same speed, at the same time. Okay, so we learned today that the value of gravitational force is 9.8 Newton. This is where we are going to stop for today. And I believe that you've enjoyed this video. Thank you very much. I hope to see you soon. Bye. Thank you for watching this video. Now you can go ahead and take the quiz.